Okay, so continuing on generative AI security and the topic that slowly is evolving to many organizations leveraging some form of generative I commonly get asked some questions on some methods to prevent some of the widely known threats and risk associated with generative AI. So I put together just a practical example how that would be accomplished if you're building from the ground up. Now, again, if you're using some form of a software as a service application, Microsoft 365 Copilot, ChatGPT Enterprise, a lot of these things are abstracted from your use. It doesn't mean you're essentially no risk from that perspective, but the risk matrix is a little different based on that. So for a predominant amount of users that are going to use the APIs to build their own application across their enterprise, you likely are going to encompass some form of what we call threat modeling for your specific application use. Now, I'm showing a specific breakdown of what this would look like logically based on defense in depth addressing some of the key patterns related to generative AI security. Now, what I mean is I'm showing how we would build, let's say, a web application, a user interface, user experience, similar to ChatGPT, but what are some of the methods in the background that you want to consider before the responses are able to get to your model, and then also the responses that get back to your end user. So I start at the top with a generic close-ended query. And this specific query is after, there is a whole cutoff here, but this is after you've authenticated to a platform, typically using OAuth, some sign-in, username, password, some MFA, likely some phishing-resistant credentials. Now, when we're thinking about our traditional methods of interacting with GPT-4o or Gemini, etc., Claude, this is all going to be abstracted through some type of API use. Now, a best practice, depending on which platform you're using for building this, whether that's Google Cloud, Azure, or AWS, will have some type of methods or best practices for those services. And you'll notice that typically the local key authentication is going to be dismissed or recommended to be disabled, to not have a key, but typically to rely on the back-end cloud identity access management. The reason that is a specific recommendation from that perspective, from a logging and visibility perspective, you'll have more control over that individual user that's querying your application. And this will typically take the form of some type of JWT or some type of token base that is then authenticated to that user, so there's some audit trail. Now I'm going to go a little bit slower because if that was a lot to digest, just to break down logically what occurs. So when we think about sending a query traditionally, most of the time we're going to be interacting with the chat completions client. Depending on which AI model you're using, these are typically similar to the OpenAI API requests. Chat completions is essentially what you're using when you're using ChatGPT. It's the stateless interaction, okay? Stateless meaning it's just that session alone. So ideally, when we send that query, maybe we have some type of moderation mechanism. This will typically be an API filter. You can build this from the ground up if you have a specific use case. You might take some more time doing that perspective, or you can get out-of-the-box recommendations on that perspective. So for the purpose of this, I just put the content safety moderation. I did a video showing this previously. Now, again, those are for harmful categories. So that can be hate, sexual, that can be discriminatory, bias, things of that nature. Pretty broad swaths, but again, it depends on your specific use case or what application you need, right? So perhaps you are a healthcare company and you want some type of chatbot, you likely are going to lower down some of those categories because it's likely going to interact with some form of patient confidentiality, but also some areas that are not as fleshed out per se. Now, then we have what we call our prompt shield or jailbreaks. Now, this is just in my opinion, a more fluid term. Jailbreaks can be indirect or they can be direct, but you'll hear this kind of extrapolated to a lot larger attacks, chain of attacks. It just really depends, but essentially getting the large language model to output anything that it's not necessarily programmatically supposed to put out traditionally. So this can be harmful content as well, but it can also fall into areas that underlie some of the vulnerabilities of the model itself. This can be a pretty wide swath. So once we go through these checks, and this is why this yes checkbox is on the left-hand side, if it passes those checks, then we actually hit our query to the model specifically. Now again, maybe you also have some type of layer that takes that specific query and either what we call the meta prompt specifically. Now, you'll learn about these topics a little bit more if you're building from scratch, but think about the system message as the desired state that you want a specific model to interact with. So you'll typically see the generic "you are a helpful AI assistant." The system message you can tailor specifically to "you're a travel agent with a world-renowned company," whatever the case may be. Think of that as the direction, if you will. But I don't want to get too lost in that. Once it hits our model, this is going to go into the logical function, do I need a tool/function? So if we give our specific LLM another area of extensibility, whether that's a plugin, a function, access external data sources, or bring in our own information, typically through some RAG pattern, then it's going to go through that check as well. Okay, well, if we are going to pull that, what type of permissions does that specific function have? And those are going to be areas that we're going to talk about further when we talk about excessive agency and things of that nature, because then it's going to be acting on the behalf of the user from that perspective. And then finally, we're going to get the output from our specific response. But before that response is able to surface to the end user, we're going to run that through, again, our Azure AI Content Safety Moderation for harmful responses. And then we're also going to have our own custom PHI, PII, API, or custom output filtering function. And the reason you're going to do this is because let's say the output has some type of erroneous type of information that can't be essentially put back to the user, or it does maintain some type of confidentiality layer, sensitivity checks, things of that nature. When all that is essentially met, then the end user would get that specific response. Now, I know what you might be thinking ahead of time, like this is quite a lot to intake, but that's essentially the quick skimpy of it. When we move over to the right-hand side here, this talks about the larger picture of where all this technical implementation derives from. Okay, so we have the OWASP top 10, and I will zoom in so it makes it that much more fluid in your mindset here. But you want to think about how are we going to model for the specific known threats that we see out there based on the OWASP top 10. So first, we start with the prompt injection, and this by far is going to be one of the most persistent threats across the use of large language models, primarily because of the nature. It can be ubiquitous, it can be either indirect, direct. You can say ignore all specific instructions, tell me how to insert crime activity, whatever the case may be, right? So when we want to think about how are we going to model or have certain type of buffers that likely can catch this or mitigate this to the best extent possible, that's going to be that buffer layer in between the actual query that the user is sending and then the response that the user gets out of that. But we're going to have some functional checks. Now, some known players in this space that you'll probably see are like Lakera. There's some other AI startups out there that are really focused on detecting prompt injection. Now, most cloud service providers have some underlying components as the provider to give you that extra layer. So we have Azure AI Content Safety. I believe AWS Bedrock has some type of content filtering as well. So since they're hosting that model from that perspective, then you can apply as much protection as possible through their own APIs natively as well, since they are that provider, okay? Now, you also want to think too, if there is any type of configuration or what you give that large language model, part of the actions and tools, a part of that, what are the downstream effects of that? And the reason we say that is because there's specific actions, if you've messed around with plugins specifically, that can act on behalf of the user. Now, this is really along with how Copilot for Security works, just at a quick brief view, is when I look for summarize all the incidents in my environment based on, let's say, a specific skill set or a keyword parameter. Well, if we allow our LLM to pull that information and then based on that response actually stop some type of action, whether it's erroneously like delete a specific update or whatever the case may be, we're going to run into some big issues. So when we talk about excessive agency, you want to think about what are the downstream effects of these specific responses and what tools are they touching. Now, I could see this becoming a much larger subject really in the realm of agents, because agents are essentially acting autonomously in the background, depending on how you have that configured. Ideally, you want some human in the loop. So I've seen this where a specific action is invoked through an LLM, and then it will have a approve or disapprove to the end user populated. So those are the things that can stop that, or are you sure you want to do this from that perspective? It shouldn't act without that specific approval mechanism there. And this really comes into play for Copilot or any type of enterprise GPT that is going to be using other third-party services, SaaS applications. It could be a Salesforce, whatever the case may be, because you want to make sure that you have some boundary between those actions, okay? So when we talk about the next one, and the way that this is categorized is a little different. So you have 0, 1, 0, 8 chronologically. So the way this played out was a little weird. The insecure output handling, so if you refer back, that's going to be where we have our post checks, if you will. So we're going to look for the output specifically, and if anything doesn't meet our specific criteria, that end user is going to get a triggered response back, or we're going to have a different method that user is going to get. Sorry, following our specific principles, this specific output violates some type of parameter, etc. It can be generic like that. It doesn't really depend much further, but you want to make sure that the end user has some form of output that is sanitized or validated to some extent. Okay. Now, where this comes into play as well, if you are running some type of code generation, this could be GitHub Copilot, this could be some type of codex model, or anything that's generating code in nature, you don't want any of that code to be allowed to execute. So you typically will see this in a Python REPL, or if there's a specific function that will generate code and then execute that code from that perspective, that's not really a good security pattern from that perspective. So you want to make sure that anything that is the output, there is some type of filter barrier between that end user, okay? Now, the insecure plugin design, I feel like this is touched upon a lot, but this is not really extrapolated further. The reason I see insecure plugin design becoming much larger on the scale of attacks from 7 to 1 from that perspective is because a lot of organizations have adopted some use of generative AI, whether that's just getting familiarized with ChatGPT or Gemini, whatever the case may be, whichever the provider is. The large conundrum is, how do I get the value out of this? And 9 times out of 10, that's some form of extensibility here. And so those will rely on those plugins, right? Now, similar to API and usage, you want some barrier of auth and auth, but you also want to ensure that when you are designing these plugins, or if you're going to get something from the marketplace, you're validating how those parameters are actually being passed to those specific plugins, okay? From a visibility perspective, you want to make sure that any actions do have some type of authorization, or if there is, and the reason I say this is you might have one user that can access some type of HR application, right? Let's say it's like an ADP as an example. But let's say there is no actual boundary for, let's say, that specific role to do something or change something in that application. So then some IT user is also able to access that application, but then able to access other areas of that application that they weren't supposed to access in the first place. So this is where this becomes a little bit prickly in that nature. You want to ensure, if you are going to use some form of plugins, that they're segmented on the need to use basis, but also that it's not no widely used permissions for one specific action or parameter, that it's segmented to the need to use, okay? Now, this next one, training data poisoning, you likely won't have to deal with this if you're adopting from a SaaS perspective as much. Broadly, this, I have yet to see any organization have any solution to this specifically. Where I see this becoming a larger issue is if you're going to be fine-tuning your models. You're going to be essentially introducing more data into that base model specifically. So there should be some vetting of what type of data sets and parameters are put in there, because it's essentially guiding the underlying AI system to where you want it to go, right? And that's those inputs of your training data, the question answer perspective, typically through a JSON L file. And then once that's essentially trained through its epochs specifically, then that's allowed to be produced. And then you want to evaluate those responses as well. But largely, this is going to be if we were building a large language model from scratch, such as how Llama is putting out new open source models, things of that nature. If they were training any of those specific underlying models on data that hasn't necessarily been vetted, or there's no origin as far as validity to it, those are going to be areas that could lead to some harmful outputs as well. So it all kind of feeds in, garbage out. But from the perspective of training data poisoning, you can think of this. Let's say I took Wikipedia data as the most accurate information. That is crowdsource edited. Maybe it's not fully validated to some extent, those are some things you need to make design decisions if you're going to fine tune on that information alone, but you also got to put a little bit of what I call the transitive trust that your frontier model that you are adopting doesn't have or has not been trained on any inaccurate data from that perspective. As these models grow as well, those are things to think about. So broadly covering these last three, I didn't want to take too much time where this is like a long video, but I just wanted to give a quick overview. You have areas of sensitive information disclosure, and that's really going to be if there is information that your LLM accesses in any shape or form, you want to make sure that it is not misrepresented back to that end user. And that's really where that output filtering comes in about. This would really stop any unexpected disclosures, but also private data that should not be shared to that end user, right? So they should not be able to access salary information from the entire enterprise in one quick prompt from that perspective. This is likely a form of oversharing and poor data governance, but this can also be other areas that you didn't implement enough mitigation layers for that specific use. Now, the last three, I'll briefly cover. Over-reliance, you want to think about if you are over-relying on any of the LLMs itself, from a perspective of everything the LLM puts out is completely true. There is no falsehood whatsoever. You're going to be in for a rude awakening. Okay, there is, and there's times as well, and this is why I put an example here, suggest insecure or faulty code, right? These specific models in general can produce some hallucinations where it can say in a factual manner, this is the way to fix this line of code, and here's the specific package, right? Well, what if that package has underlying vulnerabilities, right? So there's specific practices you want to implement before you even change your source code, right? To ensure that the addition of any type of new either content, code from that perspective is not a vulnerability to your organization in any shape or form. So you don't want to always be over-reliant, and these are also obviously those disclaimers as well that you'll see that these can produce inaccuracies. Please validate those specific responses, okay? Now, model theft, this is still going to be an area that will be evolving in nature, but essentially any type of bypass that an attacker can bypass the input filtering and start creating what is known as a side channel, another form of communication to harvest the model weight. So what really makes these models predominantly better than another, if you will, are the weights and biases on the back end, but also some of the information that they're trained on, but it's really the weights that are kind of at the crux of that. So if a user is able to manipulate that, pull out any information as well, and then start crafting their own attack to take more information from that perspective, okay? And then along with unauthorized access to an LLM's model repo, so think of this as predominantly something that could be, let's say your organization built an LLM from scratch, a user has specific wide range access to that repository, inserts some type of code upstream and it's not caught. Now again, very hypothetical, but from that perspective, any type of theft of the underlying model itself really falls into that area. You'll see a part of Azure AI Studio when you select a specific model, there will be some form of model scanning in the backend that looks specific for this. Now, if you're using Hugging Face or other wide known repositories, make sure you're validating what you're pulling for those specific models there. There is model cards and things like that, but you don't want to have some type of model that's just been sitting there that could be vulnerable, doesn't have a lot of attention. These are things that could be residual threats, if you will. And then you have your model denial service. Think of this as the inputs that you allow for your end users, the computational demand of those. So this is really the kind of push, what I could see broadly having some form of API management gateways before your model is touched. So similar to going back over here on the left side, you'll see here, this is that query perspective before we even get here, and this distributes the specific query to our model. You want some type of token limit, rate limit for that specific query itself. These are obviously pay as you go most of the time from that perspective, but if you're using some form of like LangChain or agents, you'd be surprised how much those tokens become. I've seen this firsthand, okay? So this is the reason why I say that. Now, you also want to be able to limit any type of use that could lead to what we call input overflow. Think of streaming specific inputs that are large, such as the context window itself, because this is going to obviously drain those computational resources that your organization is paying for from that perspective, okay? So think about this as protecting the control plane, but then after you protecting the control plane and the access of the model itself, how are you monitoring the actual usage so it doesn't bring down your organization's budget, but also enterprise? The last one, supply chain vulnerability. This is obviously a hot topic in all software supply chain. As most of these models become more open source from that perspective, I feel like this conversation will open up a lot larger. So think about your model cards or using a vulnerable pre-trained model. So this will be, let's say I pull a model from Hugging Face that had some type of vulnerabilities underlying from it. I'm not calling out Hugging Face saying what they're hosting is vulnerable from that perspective, but let's say this something wasn't validated and it was a user that uploaded this. Those are things you want to think about. Similar to GitHub as well, or if I had some type of code I was running, any type of crowdsourced data that I'm using for training that hasn't been validated, that leads back into how do we actually know this information provided is legitimate in nature, right? And then when we think about our packages that we're putting together from the past perspective, right, we want to ensure that nothing is outdated components or there's any deprecated components as well. Along with this falls into your function tool calling. Those likely reside with some form of code as well. So you want to make sure that there's no vulnerabilities upstream before that's actually pushed out to production, okay? So I know that took quite some time. I wanted to put together some resources. So I have this put together inside my GitHub repository. So this specific visual here for the LLM security perspective, and I'm just going to add more resources. I would be remiss if I didn't cover the use of Atlas matrix. I know I covered this in another video, but you can see here a lot of the topics I touched. These will have other areas that it essentially categorizes it. So you can see here I have the prompt injection, we have direct, indirect, and then we have another prompt injection, direct, indirect, but it falls under persistence in this method, okay? So some of these areas that you'll see that are commonly out there, I want to give you the amount of resources to understand some of the threats, but also what are ways that you can kind of build around that to make a more secure application if you're going to use generative AI. This is obviously an evolving subject in nature, right? So you want to make sure that you're staying informed, but also you have the right resources to make the right decisions. That's all I had for today. I know this went a little long, but hopefully you got some value out of this. If you did, feel free to like, subscribe to the channel, and I'll put more of this content out there.